Hi guys, we've got a probability question today where we've got a uniform distribution which is distributed over the interval a to b, and the probability density function of this uniform distribution is given by f of x equals 0.1. Now we've been given this condition here. Given that the probability that x is greater than 7, given that x is less than 8 is a third, find a and b, show clearly how you obtained your answer. Okay. So for those of you who are less familiar with uniform distributions, what we have is, we'll put some axes down just quickly, just so you kind of understand what the hell it is we are doing. So we've got x, and on this side we've got the probability that x equals x. Okay, so what we've been told that we've got a uniform distribution on the interval a to b. Now that means we've got some point here and we've got some point here. We're going to call this a, we're going to call this b, and we've got a probability density function given by f of x equals 0.1. So we've got a point on our y-axis equal to 0.1. Let's try and fit it in, 0.1. And that is just, because it's uniform, it's just distributed across this domain. Now, so what we have is we have this distribution from A to B. Sorry about the quality of my lines, it's not that great. But here is what our distribution looks like in graphical form. Now, what we can also say, because it is a uniform distribution, because it is a distribution, we know that the area that's bounded by the curve or the line and the x-axis, this area is equal to 1. So that's a good start for us. So if the area equals 1, we know that the height of this rectangle is 0.1, so it follows that the difference between A and B is going to be 10. Okay, so all this sort of, all these sort of little rules or features of a uniform distribution is going to help us later on. Okay, so let's see what else the question is asking us to do. So we have the probability that x is greater than 7 given that x is less than or equal to 8 is a third. All right, so what we're going to do is we're going to use this probability law. The probability of A given B is equal to the probability of A and B over the probability of B. Now, this is just our conditional probability sort of law or statement. So we're going to apply this to this statement that we've got up here. So the probability that x is greater than 7 given that x is less than 8. So we first have to find the probability that x is greater than 7 and less than 8. So we can actually write that as we've got the probability that we've got x is greater than 7 but less than 8. We can just write that as a domain. So we can go x is greater than 7 but less than or equal to 8. And that's got to be divided by the probability that x is less than or equal to 8. Now, this is equal to a third. Cool. So what we have now is we have the domain in the numerator of this function. We've got a probability between 7 and 8 on the x-axis. Now, we don't know where the endpoints of our domain are, but we do know what the height is. So if we have 2 points, let's say we've got 7 is here, and we have 8 is here, we know that this area in here is going to be equal to 0.1 because we have a rectangle that's 0.1 high and 1 depth and 1 width. So we have 7 and 8. So the difference is 1. It's 0.1 high, so 0.1 times 1 is, would you believe it, 0.1. So we can rewrite this as this being equal to 0.1 divided by the probability that x is going to be less than or equal to 8, and that's going to be equal to a third. Now, we've got to rewrite this denominator in terms of something like a or b. Now, what we can do is if we know that the endpoint on the low side of the domain is a. So the probability that x is going to be less than 8 is going to be the difference from 8 to the endpoint of our domain multiplied by 0.1, like we did here. So if we sort of get a bit of different color, so this probability here is going to be the difference between a and 8. So we can, if you're wondering, well, Harold, how am I going to write that? Well, let's just have a look. We'll put our 0.1 in the numerator. And this is going to be 8 subtract a multiplied by the height of this uniform distribution, which is 0.1. And that's still equal to 1/3. Cool. So what we're going to do now, we have all the information we need to solve it. So let's just move our working out up here, save space. And now we're just going to use algebra to solve it. So I'm going to cross multiply. I'm going to take the 3 up here. I'm going to take this denominator up here. And I'm going to have 0.3 is equal to 0.1 times 8 subtract a. Cool. Now I'm going to move the 0.1 over to the other side. So I'm going to divide both sides by 0.1. The 0.1s are going to cancel. And I'm left with 0.3 divided by 0.1 is just 3, is equal to 8 take a. Now, it's quite obvious then that a equals 5. Now, right from the start of our little explanation, we sort of worked out, because this probability density function has to have an area bound by the line and the x-axis of 1, we worked out that the difference between a and b had to be 10 for a uniform distribution of equal to 0.1. So if a is 5, b has to be 10 above 5. So b is equal to 5 plus 10, if you want to show all you're working out, which is equal to 15. So finally, we have our domain is going to be x such that x is an element of the real numbers given by 5 up to and equal to x up to and equal to 15. So basically what we've done here is we've spent a bit of time explaining or coming to terms with what the hell we're doing when we do a uniform distribution. What we then did is we used the properties of a conditional probability to determine what we had to do with the numerator and the denominator of this function. Now what we could then do is we could use the properties of this uniform distribution to know that if the difference of this domain we have in the numerator is just 1, then we can multiply that domain by the function and get what the actual probability of x being between 7 and 8 is, as long as it obviously lies between a and b. Once we've done that, it's just a matter of understanding that we have an endpoint of our domain, which is A. So the probability that x is going to be less than 8 is the difference between 8 and A multiplied by the probability density function. So once we've done that, it's then a little bit of, it's pretty simple algebra to get to the final domain, which we ended up being 5 up to and equal to x, which is up to and equal to 15, so between 5 and 15. So I hope this video helped. If you have any problems with any problems that it's getting into exam season, so if you're having any troubles, give us a bell. I love to solve new problems, and if you like this video, give it a thumbs up, subscribe, the usual nonsense and mumbo jumbo. But yeah, I'll see you again next time.